What if the same questions we ask about Earth's strangest places also explain weird moons, Mars terrain, and distant exoplanet surfaces? On a cold island in the Canadian Arctic, there is a landscape so empty and battered that space agencies have used it as a rehearsal ground for another world. Devon Island is not Mars. It has air-weather wildlife around its edges and human history, but parts of it feel like a planetary riddle, bare rock frozen ground impact scars, and a silence that makes every footprint seem temporary. The clean question is this: how do you learn to explore a world where the environment itself works against you? Mars is not just far away. It is a place where machinery must survive dust, cold radiation, rough ground, and long delays in communication. A rover cannot call home for instant advice. Astronauts, if they go, will not be able to rely on easy rescue. So Earth's harsh places become practice fields, not because they are perfect copies, but because they force real problems into the open. On Devon Island, one of the most important features is the Horton impact structure, the remnant of an ancient collision. Impact craters matter across the solar system. They shape Mars, the Moon, Mercury, and countless icy bodies. They expose buried material, fracture rock, create natural basins, and preserve a record of violence written into terrain. Scientists can walk across an Earth crater and ask the same basic questions a robot might ask elsewhere. What is this rock made of? Was water ever involved? Which path is safe? Which sample is worth the effort? The fascinating part is that Mars exploration is not only about rockets, it is about judgment. A world can be scientifically rich and physically hostile at the same time. Earth analog sites help teams practice the patient art of choosing moving testing and sometimes turning back. But the boundary matters. Devon Island is still Earth. Its chemistry, gravity, atmosphere, and biological contamination are not Martian. It can suggest methods, not deliver final answers. The takeaway is simple before we explore alien ground. We often begin by finding earthly places that remind us how alien a planet can feel. Some of Earth's strangest places are strange because we cannot easily reach them. Beneath Antarctica, there are lakes sealed under enormous sheets of ice hidden from sunlight and cut off from the surface world in ways that feel almost extraterrestrial. The clean question is this: if water is trapped in darkness, under pressure, and separated from the sky, can it still be a living environment? On Earth, the answer is not simple, but it is powerful. Liquid water can exist beneath ice because ice insulates pressure changes. The behavior of freezing and heat can leak upward from the planet below. In some subglacial environments, scientists have found microbial life. In others, sampling is difficult. Contamination is a serious concern, and the full picture remains uncertain. That caution is exactly why these places matter. For space, one of the biggest questions in planetary science is whether icy moons can host habitable environments beneath their frozen crusts. Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, are not just balls of ice. Evidence suggests they have oceans beneath their surfaces. Enceladus even sprays material into space from fractures near its south pole, giving spacecraft a way to sample what may be coming from below. This does not mean life has been found. It means the ingredients that make scientists pay attention may be present: water chemistry and energy. Antarctica gives researchers a grounded way to think about that problem. How do you search for life without accidentally bringing life with you? How do you drill, sample, protect, and interpret a place where the most important evidence may be invisible to the naked eye? The comparison also changes how we imagine alien worlds. A moon can look dead from the outside and still be geologically or chemically interesting within. A frozen surface may be less like a wall and more like a lid. But the boundary is essential. Earth's subglacial lakes are part of a warm, active, biologically rich planet. Europa and Enceladus are different worlds, with different chemistry, radiation, gravity, and histories. Earth analogues do not answer the life question for them. They teach us how careful the question has to be. The memorable takeaway is that the search for life may not begin under an alien sky. It may begin under ice, in darkness, where patience matters more than imagination. If there is one Earth landscape that teaches scientists not to oversimplify habitability, it is the Atacama Desert. Parts of this desert in Chile are so dry, so salty, and so exposed that they feel less like the familiar Earth and more like a warning about how difficult life can be to detect. The clean question is this: if a place on our own planet can hide biology, so well, how careful must we be when judging Mars or distant exoplanets? The Atacama is not lifeless everywhere. That is important. Earth is deeply biological, and even harsh environments can contain microbes in protected pockets. But the desert shows how uneven habitability can be. A place can have sunlight, rock, and occasional moisture, yet still be extremely challenging for life. Water may arrive. Rarely, salts can pull moisture from the air or make the chemistry difficult. Radiation from the sun can damage exposed organic material. To a spacecraft, the difference between a truly empty place and a living place, with faint traces, can be extremely hard to read. This is why Mars scientists care about deserts. Mars today is cold, dry, and exposed at the surface. Its ancient past may have included rivers, lakes, or wetter environments, but the present-day surface is tough on delicate chemistry. Earth deserts help test instruments, sampling methods, and expectations. They remind researchers that life detection is not just about finding the right planet. It is about asking the right question in the right place, with tools sensitive enough to notice subtle evidence. The lesson also reaches beyond Mars. For exoplanets, scientists usually cannot inspect a surface directly. They study clues such as size, orbit, density, starlight, and sometimes atmospheric gases. A planet might sit in a region where liquid water is possible, but that does not guarantee oceans life or Earth-like conditions. Habitability is not a label we can stamp onto a world from one clue. It is a layered mystery. So the final takeaway is humility. Strange places on Earth are not exact copies of space. Devon Island is not Mars. Antarctic. Ice is not Europa. The Atacama is not an exoplanet. But each place gives science a rehearsal space for uncertainty. They teach us that alien worlds may be harsh, hidden, or misleading at first glance. And sometimes to understand the universe, we begin by noticing how strange our own planet already is.